Chapter 11, Data Analysis and Displays. 11.1 is Measures of Center and Variation. Okay, so our measures of center that we're going to look at are mean, median, and mode. So mean is also known as the average. So we're going to be looking for the average of all these numbers. So what we're going to do to find that is to add them all together and then divide by how many data points there are. Okay, so I'm going to take my mean here is going to be 9 plus 5 plus 7 plus 4 plus 7 plus 6 plus 8. And I'm going to divide that all by how many of these there are. So I've got to count them now. 1, 2, 3, 4, 5, 6, 7. There's 7 of them. Okay. So add it all together, that would give me 46 over 7. And then if you put that into a calculator, it'll be about 6.57. And there is our mean or average. Okay. All right. Now let's look at median. To find the median of a set of data points, what we're going to do is order the data points from least to greatest. Okay, so let me do that first step here on this example. So let's see, the 4 is the smallest. Then I've got a 5 and a 6. There's 2 7s, an 8 and a 9. Okay. I'll order these while I'm at it. So the 3 comes first here, then 4. 5, 6, 7, 8, and 9. Okay, so I've ordered both of those sets from least to greatest. Now, it depends if you've got an odd number of data points or an even number of data points. If they're an odd number of data points, you just find the point in the middle. So let's see, on this first one, we've got 1, 2, 3, 4, 5, 6, 7 data points here. And so there's an odd number, so then I just find the one in the middle. It's that one, right, because there's 3 data points to the left and to the right. So that means that the median here is the number 7. Okay. On the next example, if you try to find the exact center here, the 6 isn't quite at the center, neither is the 7. Because there's an even number of data points. So you could say that these are the 2 that are closest to the center. So that's always going to happen when you've got an even number of data points, that it's really the middle's right between those 2 numbers, right? So what we're going to do in this scenario is to average those 2 numbers that are closest to the middle. So my median here, I'm going to average 6 and 7. So I'll add them together and then divide by 2. That would be 13 over 2, or 6.5. Makes sense. 6.5 is directly between 6 and 7 on the number line, right? So that's the median of that set of data points then. Okay. And then mode, mode is going to be the data point that occurs the most often. Maybe this is a silly way to remember this, but the way I remember it has an O in it, and so I think of the word occurs. It's the one that occurs the most often. Okay, so I'm just going to look for any numbers that are listed more than once. So here there are 2 7s, and then there's only 1 of everything else, so that means the mode here is 7. Okay, on this one again there's 2 7s, but there's also 2 8s. So we've got 2 numbers that are tied for most often. So you can have more than one mode. Those 2 numbers are both tied for first place if the contest is occurring most often. On this one, everything occurs once. So since everything is tied, then there's no winner. We don't say anyone's in first place if everyone's tied. Okay, so in that kind of scenario, you would have no mode. Okay. Okay, let's look at what's called an outlier then. Okay, so an outlier is a data point that is much higher or much lower than the other data points in a set. Okay, so we've got these 6 quiz scores, and we're going to try to decide which is the outlier. And maybe you can just look at it and figure it out. But another way to approach this is to graph them on a number line. So my lowest number here is 1, and then it goes all the way to 7. So 2, 3, 4, 5, 6, 7. Okay, and now let's plot these. I've got 2 5s, so I'll put those like that, and I've got a 7, I've got a 4, a 6, and a 1. So visually now you can see you've got a cluster of data points over here, and then the 1 is out there on its own. That would be the outlier. Okay. All right, so how would removing the outlier affect the mean? So first I'm going to find what the mean would be with the outlier. Okay, so if I was finding the mean of all these numbers, I'd add them all together and then divide by how many of them there are. So let's see, 1, 2, 3, 4, 5, 6. Okay, and if you put that into a calculator, you're going to get 4.6 repeating, or 4 2/3. Okay, so that's the original with the outlier. Let's see what it would look like without the outlier. So now I'm just going to average the numbers except for the 1. So 5 plus 7 plus 5 plus 4 plus 6, and now there would only be 5 data points instead of 6, and that's going to come out to 5.4. Okay, so how does it affect it? Well, the mean without the outlier is higher, right? It's definitely different. Okay. All right. Now let's see what would happen if what it would do to the median. Okay. So let's check with the outlier. To find the median, I want to put all these in order from least to greatest. So I got 1, 4, got 2 5s, a 6, and a 7. Okay, so now looking at these, I would average the 2 that are closest to the center, since there's no number right in the center. And then if you average 5 and 5, well, the average of those is going to be 5, right? Because it's 10 over 2, which is 5. Okay, and then let's find without the outlier. So I'm going to have that same list except with no 1. Okay, so this time the 5 is right in the middle, so that is the mean. Not the mean, the median, sorry. So in this case, we got the same median either way. Now that can happen sometimes, but you can imagine how in some lists it might change, right? So it doesn't change here. So I'm going to say it has the same median. But I also want to point out that it's a coincidence. So it can have the same median, but it could also change depending on the list of numbers. Okay, and then now let's see what it does to the mode. So let's go with the outlier. Well, here I'm just looking for the number that occurs most often in the original list. That would be a 5. Without the outlier, it's also a 5, right? If you just erase the 1 from that list, there's still 2 5s. So in this case, it doesn't change. It would be possible for it to change if the outlier was the mode, but I guess that would be unusual to have an outlier be a mode. But it could happen. Okay, all right. So we've been looking at these measures of central tendency. Now we're going to also look at measures of variation. And there's two different ones we're going to look at, range and standard deviation. Okay, so let's start with range. So the range is going to be the difference between the greatest value and the least value. So in this list, the 9 is the greatest. Okay, and let's see, the 4 is the least in this list, right? So all I have to do to find the range is take my biggest number minus my smallest number. That's going to give me the difference between those two. So there's a range of 5 numbers. Okay. On this list, let's see, greatest here is 7. And the least is the 1. So my range is going to be 7 minus 1. And that is 6. So the range is pretty easy to work with if you know what it is. The standard deviation is a little trickier, takes a lot more work. Okay, so standard deviation. This is going to measure how closely clustered data points are. Okay, so if you imagine there's a test, a whole class takes a test, and everyone in the class gets a 50%. Well, then 30 people, let's say, all get a 50%. And then you've got another class, and half the kids get a 0 and half the kids get 100%. Well, both classes have an average of, they have a mean of 50% in their class, but it's a very different story. In one class is very consistent, all of the data points were the same. In the other class, they had a huge range and had a big spread. So standard deviation measures how closely clustered data points are. Okay, a small standard deviation means you've got closely clustered. So that class where everyone got 50 would have a small standard deviation. The class where there's zeros and hundreds, that would have a large standard deviation. Okay, and it's quite a process to find the standard deviation. So we're going to start with the mean. And we're going to use this little symbol, an X with a bar over it, okay? And I think rather than reading through this list of all this stuff, we'll just start working through this example, okay? So first, we've got these, let's say these are quiz scores or something, 22, 25, 26, and 27. So the first thing we want to do is find the mean, okay? So I'm going to add these numbers together, and then I'll divide by 4 since there's 4 of these data points. Okay, that's going to give me 100 over 4. Means the average there is, this was for my X bar, that's the symbol for mean. So my mean is 25, okay? Now I've got this chart. The X's are just my original data points that are just listed there, okay? In this next column, I'm going to put the mean in. I just found the mean, so I'm just going to put 25 in every slot going down there in that column, okay? So if we go back to the top where I was saying to find the standard deviation, okay, we found the mean there, step 1. Next, we're going to find the deviation. This is not the standard deviation, this is called the deviation. And what we're going to do is take X minus X bar. Well, the X is the original data point, X bar is the mean. So for every one of these, I'm going to do something minus 25 because the mean is 25. So I've got 22 minus 25. In this one, I'll do 25 minus 25, 26 minus 25, and 27 minus 25, okay? And then I'll do the actual math here, and I've got -3, 0, 1, and 2. So these are the deviations. That's when you take a data point minus the mean, okay? So step 2, complete. Now we're going to square each of these deviations. I'm going to take the numbers in this column and square them one by one. So I'm going to take -3 squared. Remember, that's -3 times -3, so it's going to come out positive, right? And then I've got 0 squared, which is 0, 1 squared, which is 1, 2 squared is 4, okay? So now I squared each deviation, okay? Now, next step, I'm going to find the variance. So the variance, this is the mean of the squared deviations. So for the variance, I'm going to square these. Not square these. I'm going to average those. I'm going to find the mean of these. Okay, so I'm going to take 9 plus 0. This is for my standard deviation. 9 plus 0 plus 1 plus 4. Oh man, and this is not the standard deviation. Sorry, this is the variance. And I'm averaging them by dividing them all by 4. Okay, and I wrote the 0 in there. It's not going to change this sum on top. I'm going to get 14 when I add those all together. But it does count as a data point. So sometimes I see people write, oh, the 0 doesn't count for anything, so then I'm just dividing by 3. That's not the case. It's still a data point, even though it's 0. So there's 4 numbers there still. So dividing by 4. So hey, I could reduce that into 7 over 2, and then that would become 3.5. Okay? So this is called the variance. That's my 3.5 is the variance, okay? That's the mean of the standard deviations, of the squared deviations. Man, I keep saying the wrong words here. Yeah, it's the mean of the squared deviations, okay? The last step, the standard deviation is going to be the square root of the variance, okay? And so, hey, I just found the variance. It's 3.5. And so you could put that into a calculator, and that would give you about 1.87. And that is my standard deviation. Okay, so it's a long process. Okay, let's try another one. So these take a while. There are ways you can do these very quickly with online calculators or fancier calculators where you just basically type in the numbers and then it will tell you the standard deviation. But if you do it that way, you might not understand what you're doing. So it's important to understand what is happening and to be able to do this by hand. So that's what we're practicing here, okay? So I've got these new numbers. I'm going to start by finding the mean. So I'll add together these 4 and then divide by 4. That's going to give me, let's see, I've got 16 plus 11 would be 27. I just want to double check my math. Plus 13, that's going to give me 40 over, and there's 4 of them here. So that means 10 is the mean. Okay. All right. So next I'm going to put the mean down here into the chart. Okay. Now I'm going to do the subtraction where I take my data point minus the mean. Some of these will come out negative. So I've got -3, -1, 1, and 3. Okay. Now I'll square those deviations. So I'm going to square -3 and -1 and 1 and 3. Okay, so -3 times itself. -3 times -3 is +9. -1 times -1 is +1. And I get 1 and 9 like so. Okay. Now I'll find the variance. To do that, I'm going to average these numbers. Okay, there's 4 of them. Let's see, that would be 10 and another 10. So that's 20 over 4. That means 5 is the variance. Okay, and then the standard deviation. So remember, the standard deviation is going to be the square root of the variance. So it's the square root of 5 here, and I'll just put that in my calculator here. That would be about 2.24. Okay, all right, that's the end of the lesson, and I'll see you next time.